Welcome to the educational research section of www.happynumbers.org, Introduction to Research, and today's video is going to be on selecting a sample from a population. Pardon me. Sampling is the process of selecting a certain number of individuals for a study in such a way that they represent the larger group from which they were selected. The population, so the individuals selected are the sample, and the group that they're selected from is called the population. And of course, it is very, very important for a sample to be valid. It has to be a good representation of the population that it's selected from. And the reason for sampling, or the purpose, is most of the time we want to gain information about a population, but we don't have access to the entire population because of time or money or the amount of effort. If a sample is well selected, then research results based on it will be generalizable to the population. And that will increase the external validity of the research, which means can it be generalized? So again, it would be very difficult to have access, most of the time very difficult to have access to a total population of interest. Although every 10 years in the United States we do attempt to carry out a census, which is a counting of everyone in the population. But other than that, rarely do researchers have access to the total population of interest that they're interested in generalizing to, and so they use sampling. We're going to talk about 4 basic types of sampling. Random sampling, which under most conditions or generally is the best type of sampling. Stratified sampling, cluster sampling, and systematic sampling. But no matter what techniques, that sampling technique we're using, basically the process is the same. To identify the population of interest, determine what the necessary sample size is, and then determine the method of selecting the sample. The first method we'll look at is random sampling, and that is selecting a sample from a population in such a way that every individual in that population has an equal probability of being selected. And random sampling generally gives us a representative sample of the population. Any differences between the sample and the population should be small, and they should be unbiased. There should be no bias built in. No technique guarantees a total representative sample. However, random sampling is generally considered under most conditions to be the best and to give us the highest probability of selecting a representative sample. Let's take a look at an example of random sampling here. There are 100 letters there. 20 of them are A, 20 of them are B, 20 of them are C, 20 of them are D, 20 of them are E. Pardon, I'm going to let that phone ring, so don't let it bother you. So if I were to take a representative sample, I would expect that 20% of that sample would be A's, 20% of that sample would be B's, 20% of that sample C's, 20% D's, and 20% E's. Let me say that again because the phone was ringing. If I took a representative sample, I'd expect, well, let's suppose I took a sample of 10. Well, I would expect that 20% would be A's, 20% B's, 20% C's. So 2 would be A's, 2 would be B's, 2 would be C's, 2 would be D's, and 2 would be E, because 2 is 20% of 10. So let's see how this works. I'm going to click on the 10, and the computer's going to randomly select 10 out of the 100. And now let's see what kind of sample it created. Remember, if we want 10, there should be 2 or 20% A's, 20% B's, 20% C's, 20% D's, and so on. Well, we had 10% A's, 20% B's, 10% C's, 40% D's, and 20% E's. So obviously not totally representative of our population, but not bad for only selecting a sample size of 10. Let's try a sample size of 20. And let's Okay, with a sample size of 20, we got 15% A's, 10% B's, 5% C's, 25. So actually our sample of 20 was not even as good as our sample of 10. Let's go a sample of 70. We're going to, out of the 100, we're going to randomly select 70. Now we would expect that we should get a fairly good representative sample here. Well, we got 11%, 27, 27, 17, and 17. Still, not totally representative, but not really that out of whack. Now let's try 90. We're going to take a sample of 90, random sample of 90 out of all of these. 14, 18%, 16, 25, and 23. Not too bad. Not too bad. So that's just a quick down and dirty example of random sampling. And again, generally random sampling is the best. However, sometimes it's not practical, or it isn't the best. So sometimes we might want to use stratified sampling, and it refers to selecting a sample where identified subgroups in the population are represented in the sample in the same proportion that they exist in the population. So if we have a population that has different strata in it, then we want to see that that strata is represented proportionally, and we use stratified sampling. And you can see some examples of stratified sampling here: political affiliation, gender, ethnic background, socioeconomic status. We'll give an example here. Suppose we had a population consisting of 100,000 people, 70,000 females and 30,000 males. Well, here we have two different strata now. Way more females than males. Further, suppose we are interested in surveying their attitudes towards abortion. We have enough funding to survey 20,000. So we can't survey all 100,000 because it's too expensive. So we can only survey 20,000. Random selection of 20,000 from the 100,000 would certainly be justified. However, it might miss or hide a very important variable: gender. There may be a significant difference in how males and females view abortion. So we decide to use stratified random sampling to ensure that gender differences are representative of the population. Here's how it would work. We have a population of 100,000, 70,000 female, 700,000 female, 300,000 male. But we're using a sample of 20,000, which we want to split into 70% female, 30% male. Well, 70% of 20,000 is 14,000, and it's just, this is how the calculation of it. 30% of 20,000 is 6,000. So we would randomly select 14,000 females and survey them, and we would randomly select 6,000 males and survey them. We've divided our initial population into two strata, female and male, and then we randomly sampled each strata in relation to their presence in terms of percent in the total population. Let's take a look at another example. Now suppose we're interested in the comparative effectiveness of two methods of mathematics instruction, let's say method A and method B, for three different levels of IQ: high, average, and low. Specifically, we'll use as the population all 300 8th grade students enrolled in the general math at Why Do I Have to Be Here Junior High School. The desired sample size is 90 students, 45 in math instruction using method A and 45 in math instruction method B. Remember, we have two kinds of math instruction, so we'll call them A and B. And we have three subgroups: high IQ, average IQ, and low IQ. So, classification of the 300 students indicates that there are 45 high IQ students, 215 average IQs, and 40 low. That gives us our 300 students. So we have a population of 300 students, 45 high IQ, 215 average, 40 low IQ. We randomly select from the 45 IQ 30 students. We randomly select from the 250 average IQ 30 students, and we randomly select from the 40 low IQ students 30 students. So we've randomly selected 30 students from each group. That gives us our 90. And then we randomly assign 15 students to Math A and 15 to Math B. These are our high IQ. Our average IQ of the 30, we randomly 15 in Group A, 15 in Group B, and in the same with the low IQ. So, students are randomly selected from each of the IQ groups. That is 30 high, 30 average, 30 low, and then the 30 students are randomly assigned 15 to Group A, 15 to Group B. And that's an example of stratified random sampling. Another kind of sampling, pardon me, is cluster sampling, which uses pre-existing groups and not individuals. Many times, especially in a school setting, it is impossible, not feasible to obtain or compile a list of all of the members of the population. And so in educational settings, we may just select clusters. So clusters of classrooms. So we can randomly select clusters of classrooms. But we would not randomly assign, pick students out of classrooms and randomly assign them to this group and to that group. One of the major disadvantages of cluster sampling is you have to account for the possibility that there may be differences within these clusters. Like if I take classroom A and classroom B, there may be some built-in differences. Classroom A may be low-performing students, classroom B may be GATE students, and we have to be able to account for that. So, examples of clusters include classrooms, schools, city blocks, hospitals, department stores, and again, the advantages, chances are greater of selecting a sample that is not representative of the population. And commonly used inferential statistics are not appropriate when using cluster sampling. Systematic sampling is another type of sampling. And in systematic sampling, from a list, we take every nth name. So let's say we decide, well, let's say we have a phone book, and we're going to take every 1,000th name in the phone book. So we randomly select the first, and then we take every 1,000th name, and let's say we're going to call that person. The major difference between systematic sampling and other forms of sampling is that all members of the population do not have an independent chance of being selected. Now, one way we could counteract that is if we took the phone book and then randomized the listing in the phone book. Just randomize, totally mix up the listing and randomize it, and then systematically selected every 1,000th person. Then that would be okay. But if we didn't, then the systematic sampling of, let's say a phone book is a good example, names like Johnson and Smith would show up much more than people with unusual surnames. So that's one of the disadvantages of systematic sampling. So, here we have sample method, when it can be used, advantages, disadvantages. So simple random sampling, anytime it's feasible. Simple to use and easy to explain, and it requires a sample list. That's one of the disadvantages. Stratified, if we're concerned about underrepresentation of subgroups or strata. Cluster sampling, that's sampling when we're using existing groups, and systematic is when we want to sample every k or nth case. Well, those are 4 types of sampling that generally are used and will appear in the research, and you should be aware of the advantages and disadvantages of it. Thank you very much. See you next time.